This is AP Calculus, section 3.2, page 2. And given this function that f of x is 11x minus 17 when x is less than 2, 3x squared minus 7 when x is greater than or equal to 2 is f of x differentiable at x equals 2. The first thing that we want to check for is continuity. It's the easiest one to check. Okay, so we're going to check where f of 2 is equal to the limit as x approaches 2 of f of x. Now, because this is a piecewise defined function, we actually need to check the limit from the left and the limit from the right. So let's just expand this. Limit from the left side of 2 equals the limit as x approaches 2 from the right. All right, f of 2. 2 is defined in this piece, so 3 times 2 squared, that's 3 times 4, 12, minus 7 is 5. Limit from the left side of 2. This is the piece that's on the left side of 2. 11 times 2 is 22, minus 17, also 5. And let's hope this is the same, or hope it's not the same, then we're done, because then it's discontinuous. But if we plug in 2 from the right, oh, that's right here. That is also 5. Since all three of these are the same, then we know that this function is continuous at x equals 2. Second thing we're going to check for is slopes of tangents from the left and from the right side of 2. Prime from the left side of 2 versus f prime from the right side of 2. All right, now one of the things that we can start to do here is to recognize that the left side of 2 is this 11x minus 17. That's a line that is, I'm sorry, I'm getting a phone call and I don't want to take it. That's a line, so it has a constant slope. So we can come down here and say that this has a slope of 11 because 11x minus 17 is linear. Now this piece over here, that's coming from the right side of 2, that says quadratic, so we have to use one of our limit formulas. The easiest formula to use is this one. Sometimes it doesn't work, but it's the best one to start with. If it doesn't work, then you're going to have to go back to a limit as h approaches 0. But let's try this one. And our a value here is 2, so we want the limit as x approaches 2 of f of x minus f of 2 all over x minus 2. Oh, and we're coming at 2 from the right. I lost my little superscript there. Let's see, f of x, that's 3x squared minus 7 minus f of 2, that's 5 over an x minus 2. Simplify. We have 3x squared minus 12 over an x minus 2. We can factor. That x squared minus 4 factors into an x plus 2 times an x minus 2. This is all still over an x minus 2. And very nicely here, these x minus 2's divide out. And we have a limit as x approaches 2 from the right of 3 times an x plus 2. Subbing in that 2, 3 times a 4, which is 12. All right, now what did we just find with all of this? The slope of the tangent line from the left side of 2 is 11. The slope of the tangent line from the right side of 2 is 12. These are not equal to each other. So function is continuous, but the slope of the tangent from the left does not equal the slope of the tangent from the right. So f of x is not differentiable at x equals 2 because f prime from the left side of 2 does not equal f prime from the right side of 2. And we had specific numbers here, 11 and 12. That means that we have a corner. Perfect. Thank you very much. Please join me on page 3.